Hello students, I hope that you are good, well and fine, and today we will be continuing our discussion on the topic of relation functions, chapter 1, class 12th. And in this chapter we discussed about relations. Now it's time to discuss about functions. In functions, what we discussed the definition and other such things, types of functions and some elementary functions, and then we discussed the composition of functions and invertible function. Now in today's class, what we will be discussing on equality of functions, and then we will practice some questions. Okay, so let's see, what do we mean by equal function when we say that two functions are given to us are equal to each other. So if two function f and g are given to us, okay, and we want that they are equal to each other, in notation we say that say f is equals to g. Okay, if and only if there are two conditions which must satisfy. First, the equality of relation. What this means, the relation corresponding to f denoted as rf, say, is equal to the relation corresponding to g denoted as rg. What it means? This means that for every pair xy in rf, there is an identical pair in rg and vice versa. Okay, so if you try to see what do we mean by that, in other words, fx is equals to gx for all x in the domain of f and g. Okay, let's say the relation for r is rf, and we have pair 1 2 2 1 2 and 1 1, say. Okay, and for g the relation is as like this, 1 1 and 1 2. Okay, as now you can see that pick any pair over here, you will have the identical pair in rg for this, like this. Okay, so that's it. We talked about in this first point the equality of relation, or in other words, if you can say that fx is equals to gx for every x in domain of f and g. Okay, now there the other condition is also important. Okay, so what other condition we are talking about? We are talking about the equality of domains. Okay, so equality of domains must be there. This means the equality of codomain. Okay, so the codomain of f is equals to the codomain of g. So what this means in total, from 1 and 2 point, what we can say is that if f is defined from a to b, then g must also define from a to b. Okay, a to b, the equality of codomains. Okay, and this condition requires that the set of all possible outputs or the target set for both function must be the same. Okay, so the set of all possible outputs or the target set for both functions must be same, even if the actual output of the function are a subset of these codomains. Okay, so first is that if we have two functions f from a to b and g must be also a function from a to b, then we will be talking about two functions are equal when fx is equals to gx for every x in the domain of g and f. Okay, I hope that from definition it is quite clear to you. Okay, let's move next, so that we can now it's time to move on to the questions, so that you can get the theory applied over there. So how a theory plays role to solve questions, let's see. Okay, so in this question, what it says that one function f from R to R defined like this and g from R to R defined by this. So we have to find the composition of g of f, okay, and also f of g. If you recall, when we define the composition of two functions, first, if my composition is like this, okay, if my composition like this, then the codomain of f, must be equal to the domain of g. Okay, so this means if f is defined from A to B, then the function g must be defined from B to any set C. Okay, then only we can define the composition like this. Okay, so as you can see over here, for g of f, the codomain for f is R and the domain for g is also R. So we can find this function, as well as we can also find this, because the codomain for this is equals to the domain for this function, which is R. Okay, now let's find out. So g of fx, this means g of fx. What is fx? Fx is 2x plus 3, 2x plus 3. Okay, now let's see. Gx means g of input is equals to input whole square. Yes, so this means from this g of input will be what? Input whole square. Yes, so this means what is our input? This. So 2x plus 3 whole square, or you can open this square, you will get 4x square plus 9 plus 12x. So the simplified expression will be like this, or your final g of fx will look like this. Okay, now let's find for f of gx. Now f of gx will be what? F of gx. Okay, and we know what is gx. Gx is x square. So x square, as you can see, gx is x square. Now observe fx. So f of input is equals to what? 2 times input plus 3. Yes, 2 times input plus 3. So this means what we will do, we will apply same over here. So this is my input, and f is what? F is 2 times input plus 3. So this means 2 times input is x square plus 3. Your final expression will be 2x square plus 3. Okay, I hope that you got the same expression as these. Okay, let's move next question. Now this question says that if hx is defined like this, hx is equals to 3x minus 7. First of all, we need to show that h is invertible. So whenever you need to show that my function is invertible, always show what? First it is 1 1, the function given, the given function is 1 1. Second, the given function is onto also. Okay, so if you showed both of these conditions, then your function will be what? Invertible. Let's show. So 3x minus 7. So hx is what? 3x minus 7. Okay. And also your say h is from R to R. This is there. Sorry for that it is not written, but h function is from R to R. Okay. Now let's prove. First 1 1. So to show 1 1, we always start with what? We always start with what? F of x1 is equals to f of x2. And from this, what we try to conclude? We always try to conclude that x1 is equals to x2. Okay, let's see that we can prove or not. So fx1 is equals to fx2. This means 3x1 minus 7 is equals to 3x2 minus 7. Just do some manipulation, you will get this. And dividing by 3 both side, what you will get is this. So hence it is 1 1. Okay, now let's show that it is the hx is what? Onto. So to prove onto, we always to prove onto, we try to show what? That the range set or the values of y, the set of values of y is equals to the codomain. Here codomain is what? The set of all real numbers. Okay, let's see. So first of all, put hx is equals to y. Okay, 3x minus 7. Now try to find out equation x is equals to expression in terms of y, expression in terms y. Okay, so how you are going to find that? It is quite easy. Just do some rearrangement of variables and constant. What you will get is this: x is equals to y plus 7 by 3. This is your equation such type. Okay, now what we know? First of all, we know that x or y plus 7 by 3 is equals to x, and this x belongs to the real number. So this means this whole thing must also belongs to the real number. Okay, so now try to think that what value you can think of so that this condition satisfy, that you apply the value you think you thought, and the whole thing must belongs to the real number set. Is there any restriction? You also write it down. Okay, so as you can see that you can put any real number over here and you will get this number as also any this number as also some real number. Okay, so this means from this you can say that y can be any real number. Y can be any real number. So this means the set of all y values is equals to the R, and this is what? The codomain. Yes, so this means the range set is equals to the codomain set. This means that my function is onto. So it is onto, hence we showed that it is invertible. Now let's find out the inverse. So how we are going to find out the inverse? So inverse is just nothing but this function. This function is my what? Inverse. So x is equals to y plus 7 by 3. Yes, x is equals to y plus 7 by 3. Now what? Just replace x to y and y to x. Okay, y is equals to what? X plus 7 by 3. Now what? Now put y is equals to f inverse. You will get f inverse x is equals to x plus 7 by 3. So this is your f inverse. Now let's verify it. If it is the inverse of the given function f, then what you will get? F of f inverse, you will get x, and as well as f inverse of f, you will get x. So let's see. So f of f inverse x will be f of f inverse x, and we know what is my fx. So fx is equals to what? Fx is equals to 3x, not fx, it is hx. Sorry for the different notation. So it must be h. Okay, h. Okay, so hx is what? Hx is 3x minus 7. 3x minus 7, and your h inverse will be, so here also must be h inverse. Okay, so h inverse is x plus 7 by 3. x plus 7 by 3. Okay, now let's evaluate this composition of functions h and h inverse. You will get h inverse is what? H inverse is x plus 7 by 3. Now h is what? H input is equals to 3 times input minus 7. Yes, so here what is my input? Input is this. So input is this. So what I will write is 3 times input minus 7. So 3 times input is this, x plus 7 by 3. What you will get? This will get cancelled. You will get x plus minus 7, and the final answer will be x. So as you can see, and I am leaving this for you, and you will find out that this is indeed equals to x. So this means we verified that h inverse will be what? H inverse will be x plus 7 by 3. Okay, I hope that now you can do any question based on invertible functions, and you can find out its inverse also. Okay, let's move to next. Now consider the functions f from r to r x square and gx x square from r to r. Not r to r, f is from r to r, let me write properly, and gx is from r to r positive. R positive means a set of all positive real numbers, so r positive. Okay, so as you can see, okay, on the definition, based on our definition, the codomain also must be equals to each other. Here the codomain not equal to each other, so according to our definition, the function f not equals to g. Okay, so we only talk about the equality of functions when codomain are given to us equals to each other. Okay, so I hope that it is clear to you. Okay, now let's move to next. Given function fx is equals to root x. Okay, fx is equals to what? Root x, and gx is equals to what? X plus 1. Okay, now what? Now evaluate f of g. So we need to evaluate f of g and g of f at what? We need at the input when input is 4. So this is what we need to find out. Okay, we are considering all the necessary conditions are satisfying for this question, because if not, then we cannot find out the composition. So we are assuming that the f and g functions having same domain and codomain. Okay, same domain and codomain. Okay, now what? Now, not same domain and codomain. Okay, so yes. So if f is from A to B, then G must be from B to A, as like this. So the domain of f must be equals to the codomain of G, and codomain of f must be equals to the domain of G. So I want to say that. Okay, so f and G having so we are assuming that f and G functions having same not like this, let me rewrite it. So we are assuming that codomain of f is equals to the domain of G, and domain of f is equals to the codomain of G. Okay, now it's good. Now what? Let's find out. So first of all, to find out f of G4, so let's find out f of G. So f of G4 will be what? F of G4. Now G4 value will be what? Let's find out. G of 4 will be 4 plus 1, which is equals to 5. So f of 5. Now what will be the value for f of 5? So f of 5 we can find out from over here. So f of 5 will be root 5. So your final output will be root 5. Now for G of f of 4 will be G of f4, and f4 if you can find out from here. Okay, so from here, from this I am writing over here. So f of 4 will be root of 4, and root of 4 is equals to 2. So this means G of 2. Now from over here, G of 2 will be G of 2 here. G of 2 will be 2 plus 1, which is equals to 3. So for G of fx at 4, your output will be what? 3, and for this your output will be root 5. I hope that it is very clear to you. Let's move to next. Now, given fx from R to R, we are also considering my function f from R to R. Okay, so the function is like this. Now find the inverse function f inverse. Okay, is the inverse function also linear? So let's first of all find out that the inverse of this function is okay. So what is my inverse function for this function? Okay, so as you can see that it is indeed 1 1. It is 1 1 as well as on 2. By graph you can see that your graph will be what? Line. Okay, and the line, if x is 0, your y will be 2, and y when y will be 0, when it is like this. So if x is what? X is minus 2 by 5, your graph will look like this. Okay, from here you can perform that horizontal line test, and you will find out that your horizontal line will exactly cut at a point, okay, at a single point, not more than that, okay. And as you can see that it will cover all the, or you can easily see from this graph that your output value, output set is equals to the R, and R is what? My codomain. So this means this is onto also, okay. I hope that it is clear. That's why we are directly asking for what? F inverse. So F inverse. So let's find out. So in order to find out the F inverse, what we need to do? Just plug fx is equals to y. This implies y is equals to fx plus 2, and try to find out x is equals to expression of y. So how we are going to do that? It is quite easy. Fx is equals to y minus 2, x is equals to y minus 2 by 5, and in this just replace x by y and y by x, replace x to y and y to x. You will get what you will get. You will get y is equals to x minus 2 by 5, and from this y is equals to x minus 2 by 5, and this implies your F inverse x is equals to what? X minus 2 by 5. Now just verify that f of F inverse is equals to x is equals to F inverse of f, okay. So let's verify. I am going to verify this, you do for this, okay. So let's do it. So f of F inverse will be like this, and f of F inverse is this, x minus 2 by 5. We know what this is. What is my f? F is this. So f of input is equals to 5 of input plus 2, okay. F of input is equals to 5 of input plus 2. So here if you see, this is my input. So input, so this means 5 of input is equals 5 of input plus 2, okay. So 5 of input plus 2. Input is x minus 2 by 5. So this means x minus 2 by 5 plus 2. You simplify it, what you will get is x. So I have showed that indeed it satisfies this condition, okay. So this means by just definition it is inverse of the given function fx is equals to 5x plus 2, okay. I hope that it is clear to you. Now the second part of this question says that is it that the inverse function is linear. So when do we say that my function is linear? We say when the when your x power is 1, exactly 1. So as you can see over here, yes, indeed your inverse function is linear. Indeed your inverse function is linear, okay. Okay, so let's move to next, okay. So let's move to next. Now we have to find the inverse of this function. So directly just find the inverses. So putting fx is equals to y is equals to 2x minus 1, and then try to write x is equals to expression of y. So this means y plus 1 is equals to 2x. This further implies what? This further implies that x is equals to y plus 1 by 2. Now replace x to y and y to x. So this means what you will get is y is equals to x plus 1 by 2, and now what you will do, just replace y is equals to y inverse, replace, you will get what? F inverse x is equals to x plus 1 by 2. So this will be your inverse for this function. You can verify that f of f inverse is equals to x and same as f inverse of f. Okay, I hope that it is clear to you. So that's it from my side. We will meet next time. So thank you for now. Thank you again.